Okay, so we got a question right here. The photograph shows a jumping toy. The head is pushed down onto the base, compressing a spring. When released, the spring expands and the toy jumps into the air. A student investigated the toy. The student placed the toy on a balance to measure the force required to compress the spring. The force was 14 newtons when the spring was fully compressed by 1.7 centimeter. When the toy was launched, it jumped to a height of 1.5 meters, showed that the maximum energy stored in the compressed spring was about 0.1 joules. We know that the maximum energy stored in the compressed springs comes from a formula of E is equals to 1 by 2 times the force times the change in distance, or basically distance, right, from like the from the that the spring that was compressed downwards, right? So basically we have the force as 14 newtons, right? So we can write this as 1 by 2. Force is 14 newtons that was applied onto the spring, and then we have the distance that it went from the original distance to the compressed distance, right, from here to here, right? So which is basically 1.7 centimeters, which can be written as 1.7 divided by 100 meters, because the SI unit of basically the distance is meters, right? So we have to convert it. So we're gonna write it right here like 1.7 by 100, and then you get your answer as 0.119 joules, which is if you round it off, which is 0.12, because we can see the values are in two significant figures, right? So I have written as this as two significant figures, right? So this is the answer.